I've been asked to implicitly differentiate the equation tangent of x over y is equal to x plus y. And I've done several implicit differentiation videos, but this tends to be one of the biggest sources of pain for first-year calculus students. So I thought I would give at least another example. It never hurts to see as many as possible. So let's do this one. So to implicitly differentiate this, we just apply the derivative with respect to x operator to both sides of the equation. The derivative with this respect to x, the derivative of the left side with respect to x, is the same as the derivative of the right side with respect to x. And the right side is going to be very straightforward, but the left side is a little bit tricky. So let's do that on the side over here. Let me write the left-hand side a little bit differently. And I'm going to do it in a different color. Let me say that a is equal to the tangent of b. And let me say that b is equal to x over y. Then a is clearly the same thing. I mean, if I just substituted b back in here, a, this whole thing I could rewrite as just a. So if we're taking the derivative of a with respect to x, that's what we want to do right here, right? We're just trying to figure out, let me just take the derivative of both sides of this. This would be the derivative of a with respect to x is equal to the derivative of x with respect to x. Well, that's pretty straightforward. That's just 1 plus the derivative of y with respect to x. So let me write it like this. I'll write the derivative operator, the derivative of y with respect to x. That's all we did. We just applied the derivative operator to y, and we don't know what this thing is. We're going to solve for it. But obviously, I can't just leave this here, the derivative of a with respect to x. We need to solve for a. And a is just this thing right here, right? A is tangent of b, and b is just y over x. And the reason why I wrote it this way is because I wanted to show you that when you take the derivative of this, it just comes out of the chain rule. It's not some type of new voodoo magic that you haven't learned yet. So the derivative, let me just write down the chain rule right here. The derivative of a with respect to x, the derivative of a with respect to x is equal to the derivative of a with respect to b times the derivative of b with respect to x. That's just the chain rule, and it's very easy to remember because these the db's cancel out, and you're just left with the derivative of a with respect to x if you just treated these like regular fractions. So what's the derivative of a with respect to b? What's the derivative of a with respect to b? Well, that's just 1 over cosine squared of b. And if you don't have that memorized, it's actually not too hard to prove to yourself if you just write this as sine of b over cosine of b. But this tends to be one of the trig derivatives that most people memorize. I think I've already made a video where I prove this. In some books, they'll write this as secant squared of b. But we know that secant squared is the same thing as 1 over cosine squared. And I like to keep it in kind of the fundamental trig functions or trig ratios as opposed to things like secant and cosecant. And then what's the derivative of b with respect to x? What's the derivative of b with respect to x? So this is pretty interesting. Let me rewrite b, actually. Let me write b is equal to x times y to the minus 1. So the derivative of b with respect to x, we could do a little bit of chain rule right here. We could say, let me write this. The derivative of b with respect to x is equal to the derivative of x times y to the negative 1. So the derivative of x is 1 times y to the negative 1 plus the derivative of y. So let me just write this. Plus the derivative with respect to x of y to the minus 1 times the first term, times x. So this thing right here, and clearly I haven't completely simplified it yet. I still have to figure out what this thing is here. But I just simply applied the product rule here. Derivative of the first term, derivative of x is 1 times the second term, plus the derivative of the second term times the first term. That's all I did there. So the derivative of b with respect to x is just this thing right there. So it equals, let me do it in the yellow. So it's times, this is, well, I'll do it in the blue since I already wrote it. This is the blue. Derivative of b with respect to x is y to the minus 1, or 1 over y, plus the derivative with respect to x of 1 over y times x. So let me write that down here. So we just figured out, or we're almost done figuring out, what the derivative of a with respect to x is. And we could throw that in there. But we're not done. What's the derivative of 1 over y with respect to x? Well, we just do the chain rule again. We just do the chain rule. And I want to be very clear with this. And I know this might seem a little bit cumbersome what I'm doing here, but I think it might make a little bit of sense. Let me just set c is equal to 1 over y. So the derivative of c with respect to x, just from the chain rule, is equal to the derivative of c with respect to y times the derivative of y with respect to x. What's the derivative of c with respect to y? Well, this is the same thing as, I could rewrite this as y to the minus 1. So it's minus y to the minus 2 power. That's what this thing is. This thing is that right there. And I don't know what the derivative of y with respect to x is. That's what we're trying to solve for. So it's that times the derivative of y with respect to x. That just comes out of the chain rule. So this thing right here, this is exactly, this is the derivative of this thing with respect to x, which is the same thing as the derivative of c with respect to x. So I can write this little piece right here. I can rewrite this little piece as minus y to the minus 2 dy dx. And then, of course, that there is times x. And then we had the plus 1 over y. And all of that was times the 1 over cosine squared of b. So now we've simplified this a good bit. And I hope going into the chain rule didn't confuse you, because I really want to hit the point home that all of these implicit differentiation problems, these dy dx's just don't. It's not some just rule that you should memorize. They come out naturally from the chain rule. So we solved dA dx. That is equal to this expression right here. So let me write it. It's equal to 1 over cosine squared of b. Well, what's b? I wrote it. It's x over y. Cosine squared of x over y times all of this stuff over here, times all of this mess. 1 over y plus, or maybe I should say minus, if I just simplify, this is x over y squared, times dy dx, And then that is equal to the right-hand side. It is equal to 1 plus, there's an equal sign there, 1 plus dy dx. And now all we have to do is solve for dy dx. So let me just review how we got here. And you could, I went through the chain rule at every step of the way. But once you get the hang of it, you can literally just go straight down this way. And the way you think about it is, the right-hand side, I think you get it. Derivative of x is 1. Derivative of y with respect to x, well, that's just dy dx. But the left-hand side, you take the derivative of the whole thing with respect to x over y. So that's just, the derivative of tangent is 1 over cosine squared. So it's 1 over cosine squared of x over y. And you multiply that times the derivative of x over y with respect to x. And the derivative of x over y with respect to x is the derivative of, and it gets complicated, that's why it's good to do it on the side here. But it's the derivative of x, which is 1, times 1 over y, which is that term, plus the derivative of 1 over y with respect to x, which is minus 1 over y squared dy dx from the chain rule times the x. And that's why it was good to do over the side so we don't make a careless mistake. But once you get used to it, you can actually do that in your head. And of course, that equals the right-hand side. So from here on out, it's just pure algebra just to solve for our dy dx. So a good place to start is to multiply both sides of this equation times cosine squared of x over y. And so obviously, that'll turn into 1 on this side. And the left-hand side will be 1 over y minus x over y squared dy dx is equal to, I have to multiply both sides of the equation times this denominator right here, is equal to cosine squared of x over y plus cosine squared of x over y dy dx. And now what can we do? We can subtract this cosine squared of x over y from both sides of the equation. And we get 1 over y minus cosine squared of x over y. All I did is I subtracted this from both sides of the equation. So it's essentially I moved it over to the left-hand side. And what I'm trying to do is I'm going to try to separate the non-dy dx terms from the dy dx terms. So I want to bring this dy dx term over to the right-hand side. So let me add x over y squared dy dx to both sides. So then that is equal to x over y. And let me write that in the color that I originally wrote it in. A slightly different color. So that is x over y squared. I'll write the dy dx in orange. Dy dx. And then you have this term plus cosine squared of x over y dy dx. Dy dx. I think we're in the home stretch. Let's factor this dy dx out from the right-hand side. So this is equal to dy dx times x over y squared plus cosine squared of x over y. And that is equal to this thing over here. It's equal to 1 over y minus cosine squared of x over y. Now to solve for dy dx, we just have to divide both sides of this equation by this expression right here. And then what do we get? We get, if we just divide both sides by that, we get 1 over y minus cosine squared of x over y divided by this whole business right there. X over y squared plus cosine squared of x over y is equal to our dy dx. And then we're done. We just applied the chain rule multiple times, and we were able to implicitly differentiate tangent of y over x is equal to x plus y. And the hard part really is getting to this step right here. After this step, it's literally just pure algebra just to solve for the dy dx's. And then you get that answer right there. Anyway, hopefully you found that useful.